Hi, my name is Nathan Kavalik, and I work with Isaac Carson. Have you ever sat down to begin a jigsaw puzzle and found that before you can start putting everything together, you need to first sort out the puzzle pieces by color and edge type? Doing this step can really help make the process of putting a puzzle together way less daunting. Instead of looking through hundreds of pieces for a potential match, if they are sorted out, the user has fewer pieces to check before finding a match. The process of sorting puzzle pieces can be tedious and take up a lot of time, which might be annoying for some people who just want to start putting the puzzle together. If there was a way to automate this step in the puzzle building process, the user could save time manually sorting the pieces and actually focus on what they like, putting the puzzle together. Over the last month, our ME435 group has learned the basic concepts for advanced manufacturing using a Doughbot in the mechanical engineering lab. We then applied what we have learned to solve the issue of automating piece sorting for puzzles.
In our first lab, we learned the basics of the Doughbot system, including how to connect the Doughbot to the computer and also how to home it. We also learned how to use the Doughbot software and program blocks to move the robot and have it do different functions. We also learned how to program the suction end attachment and the conveyor belt. Additionally, we learned about the IR sensor, which can be used to stop the conveyor belt whenever it senses an object in front of it. Thirdly, we learned how to implement a camera, which can be used to scan the work area for objects. These components we learned during week 1 were used to help identify and move around puzzle pieces in our project. In Lab 2, we built on the skills we learned in Lab 1. We first learned about image acquisition and processing, which uses the camera setup and software on the computer to accurately identify objects that are placed in the camera's view. We also learned about calibration, point-to-point measurement, color extraction, and the blob command. We did not use these features in our portion of the project, but the group that we worked with did.
In Lab 3, we learned the basics of robot-to-robot communication. This required the setup of a circuit on a breadboard, which we connected both of the Doughbots to. This allowed for signals to be sent back and forth between the robots. We used this feature in our project as well. Whenever our robot finished sorting a puzzle piece by edge type, our robot would send a signal to the other robot, which triggered it to begin its flow and start sorting the pieces by color. This section of the video breaks down each part of our flow and shows the Doughbot completing our group's portion of the puzzle piece sorting.
In order to achieve our goal of sorting puzzle pieces, we needed to have 2 Doughbots working simultaneously. We found that using standard puzzle pieces were too thin, and the IR sensor was not able to consistently recognize them, meaning the conveyor belt would not stop. To get around this issue, we 3D printed puzzle pieces that were more thick. We paired up with another group to achieve our goal, and we separated the tasks evenly. Our group focused on taking the pieces off the conveyor belt and sorting them based on whether they were an edge piece or an inner piece. The other group would then get a signal from our robot and begin its flow, which was sorting the puzzle pieces by their color. The end result of our project was puzzle pieces sorted into 6 groups based on edge type and color. Our robot was able to consistently sort the pieces into the correct pile, but the group we worked with had challenges with the code they were using, and we were unable to get everything working at the same time. This is what the final sorting would have looked like.
After starting the code on the computer, the conveyor belt starts moving. Once the first puzzle piece comes into the view of the IR sensor, the red light comes on and the belt stops. The Doughbot moves to pick up the puzzle pieces and place it onto the work surface. For this task, we used the suction cup end attachment, which worked well with the puzzle pieces since they have a flat top surface. Next, the Doughbot moved out of the way of the work surface, and the camera took a picture of the puzzle piece. We used image matching to match whether the piece was an edge or inner. For this to work, we needed to use a photo of an edge piece for the robot to base its match off of. We used an if module to categorize the output of the match block. When the piece was identified as an edge piece, the code would output a 1, but when the piece was not identified as an edge piece, the code would output a 0, since it wasn't a match, and we would know that the piece was an inner. After this, we used a branch block to make the flow go in different directions based on the result of the piece match. When the if module returned to 1, the branch went to the left. When the if module returned to 0, the branch went to the right. Once the branch was complete, the Dough-Bot would suction the puzzle piece and move it to a specific position depending on the edge type. We had the inner pieces placed on the left and the edge pieces placed on the right. We also made sure to place the pieces in a spot that the other group's robot would be able to reach. Finally, our robot returned to its starting position and sent a signal to the other team's robot, which caused the light to turn on and signaled the other robot to begin. Our robot then waited for a set amount of time before beginning the flow over again. This ensured that the robots would not run into each other. Here's another example of the flow, this time using an edge piece, meaning that the Dough-Bot will place the piece on the right instead. Lastly, this blue piece will be placed on the left, since it's an inner.
Throughout this video, we have explained the concept and technical details for our Dough-Bot project. We set out with the goal of automating the process of sorting puzzle pieces using 2 robots. Doing this takes away the human need for sorting each piece by hand, which can be boring and repetitive. During this project, we learned about using the Dough-Bot coding interface, robot-to-robot communication, and planning out the process and workflow for our project. Thanks again for watching.